In the next lecture, we'll study detail about the phasor diagram. Okay, phasor diagram, like, don't confuse with the phasor diagram. Generally, students find it difficult to how to draw the phasor diagram, but this is the important topic. Okay, and the easy one also. Basically, we are having three types of load. One is the resistive load, right? Another one is the inductive load, right? And another one is the, tell me, capacitive load. Correct? So in resistive load, we are having current and voltage are always in same phase. You know what do you mean by the same phase? Same phase means if voltage is on the x-axis, then current would also be on the x-axis only. Okay. Now in the case of inductive load, current lags voltage by an angle phi. Okay, current lags voltage means if voltage is on the x-axis, okay, current is lagging means down. Okay, by an angle of phi is how much? That is 90 degree. Why it is 90 degree? If it is a pure inductor means only there is a inductor, then in that case phi value is fixed, that is 90 degree. Okay, now in case of capacitive load, current leads voltage by an angle phi. Okay, leads means if voltage is on x-axis, then current is leading, means current is on the upward side. Again, yeah, again phase angle would be how much? 90 degree. Pure capacitor. Okay, that is for the pure capacitor. Phase angle is equal to 90 degree. What do you mean by the impure inductor or impure capacitor? Means impure inductor, if there is a combination of R and L, then that means that is an impure inductor. Okay, for that we have to calculate the phi value, and according to the impedance triangle, you know what is phi value. If we'll calculate it according to tan phi is how much? Tan phi is XL by R. So phi would be equal to tan inverse XL by R. Okay, similar with the case of impure capacitor, that is R and C. Correct? So in this case phi, tell me the value for the phi. Tan inverse XC by. Okay, now see, this thing you need to remember, that which is lagging and which is leading. Okay, you can simply remember by the one word, civil. You know now what is civil? Okay, civil you have word, listen about it. C stands for here capacitor. Okay, C here for capacitor. You can see in case of capacitor, current is leading the voltage. Okay, current is leading the voltage. So as I told you, current capacitor, current is leading the voltage, means current is first, voltage is second. Okay, next L stands for the inductor. L is denoted by the inductor now. So in this case, V is first and I is later on, then in that case voltage leads current. Okay, I said that I current lags voltage means voltage leads current. Like there is one thief, yeah, there is one thief and there is one police, right? So if thief is lagging, then police is catching the thief, right? So it's one and the same statement. If current is leading the voltage, then obviously voltage is lagging the current, and vice versa is also true. If current is lagging the voltage, then voltage will leads the current. Okay, and for resistor you don't need to remember because both are in the same phase. Okay, So now you just need to remember the civil. C stands for capacitor, and in this current is leading, and you can remember it like that also. Inductor, obviously if current, in case of capacitor current is leading, then in case of inductor current is lagging or voltage is leading. Clear? Any doubt up to here? Good. So basically this one is the phasor diagram. If there is a not an angle of 90 degree, so suppose there is a case of capacitor, voltage will always take as a reference. Okay, reference means always will take as a on the x-axis. If there is a impure capacitor means there is a combination of R and C. So in that case the current would be, sorry, the current would be leading, right? But it's not fixed that it is 90 degree. There may be some angle phi, that phi angle we need to calculate it. Okay, now there is one more term, that is power factor. As I told you that there is three types of load. One is resistive load, another one is inductive load, another one is capacitive load. In resistive load, as you can see that phase angle is 0, right? Why phase angle is 0? Because both current and voltage are in the same phase, right? So phase angle is 0. And cos phi is the power factor. Power factor is what? The cos phi. Cos phi means the cos 0. Okay, and cos 0 is how much? 1. Okay, so we can conclude that in the case of resistive load there is a unity power factor. Okay, unity stands for 1 and PF stands for power factor. In case of inductive load there is always a lagging power factor because current is lagging. Okay, if there is a case of capacitor, then we'll always say there is a leading power factor. Okay, because current is leading. Understood? Now generally question comes like, why inductor does not consume power? Okay, so as you know that inductor uses which power? Active power, a reactive power, or apparent power? Tell me. Reactive power. If we'll use resistive load, then active power is used. If you will use inductive or capacitive load, then in that case reactive power is used. Okay, and if we'll use the combination RL, RC or RLC, then in that case apparent power is used. So why inductor does not consume power? Because inductor consumes reactive power, that is VI sin phi, right? And phi here is also 90 degree because they said pure inductor, and in case of pure inductor phi is 90 degree, so it will become 0. Okay, understood?